Welcome to My Homework Awards. Today we're going to solve question number 8 from chapter 12.1 in Calculus Early Transcendentals, 7th edition by Stewart. The solution to question 7 and 8 posted here will be available for download on MyHomeworkRewards.com in the link below. So the question asks us to find the lengths of the sides of the triangle PQR. And then furthermore asks us if this is a right triangle or a isosceles triangle. So again, we're going to solve question 8. So essentially we have 3 points in 3 dimensions. There's an x, y, and a z coordinate. And it represents 3 vertices of a triangle that we've drawn out here in 2 dimensions. So the question asks us to find the length of each of these side lengths of the triangle, and then asks us to classify it as a right angle triangle, so if any of these angles are 90 degrees, and whether or not it's an isosceles triangle. Isosceles triangle has 2 lengths equal. So the steps to solve this problem are, first we're going to calculate the magnitude of each of the side lengths, and we're going to do so by creating a vector for each side. And then next we're going to classify the triangle, checking if it's a right angle, likely using Pythagorean Theorem. So let's get started creating a vector for the side length PQ. We know the points in 3 dimensions, so what we can do is we can create a vector. Now it doesn't matter if we create vector PQ or QP, they're going to have the same direction. And we're really only interested in the magnitude. So the magnitude of vector PQ is going to equal the square root of the x, y, and z coordinates squared. Let's see if I can fit this. All right, so now this represents the x, the y, and the z coordinates. To get the x coordinate, we want to take the x coordinate of Q and subtract it from the x coordinate of P. You can think of it as like using a slope formula, final minus initial. So for the x, we have 4 minus 2. For the y, we have 1 minus negative 1. And for the z coordinate, we have 1 minus 0. So this is going to give us the square root of 4 plus 4. That looks like a 4. This is supposed to be a minus 1. That's better. Plus 1 equals the square root of 9, which equals 3. So what that means is the magnitude of that side length is 3. So you can pause the video right now if you'd like to attempt to find the other side lengths using a similar methodology. So next what we'll do is we'll find, so that was PQ, now we're going to find QR using the same steps. So again, we only care about the magnitude of the vector. And we want the x, y, and z coordinates of this vector. And then to take the magnitude, we square each of them, and then take the square root of that term. So for this one, we're going to do r minus q. So for the x coordinate, 4 minus 4. For the y coordinate, minus 5, minus 1. And for the z coordinate, 4, minus 1. So let's write that all in. 4 minus 4 on the x coordinate, minus 5 minus 1 for the y coordinate, and 4 minus 1 on the z coordinate. So this gives us a square root of 0, 36, and 9, which equals the square root of 45. So to simplify this, we think of splitting up that 45 into a multiplication that includes a perfect square number. So we can say 9 times 5. Separate that into square root of 9 times square root of 5, which equals 3 root 5. So again, we use the same methodology. It doesn't matter which way we point the vector, and then we find the x, y, and z coordinates and take the magnitude. So the last one, I'll move a little quicker here. This is going to be the magnitude of vector RP. And again, we're going to square the x, y, and z components. So here we're going to do p minus r, which is 2 minus 4 in the x direction. It's -1 minus -5 in the y direction, and 0 minus 4 in the z direction. Simplifying this gives us 4, 16, and 16, which is the square root of 36, which equals 6. So to summarize, actually I'll draw it on the triangle. So the magnitude of PQ was 3, and then QR was 3 root 5, and RP was 6. So now we have the magnitude of all the different side lengths. Because all the lengths are different, that means the triangle is scalene, not isosceles. Last thing we'll do is we'll check whether or not this is a right angle triangle. So to do so, we'll use Pythagorean Theorem. We'll check if a squared plus b squared equals c squared. So the only tricky part here is figuring out which one is c. That's going to be the hypotenuse, which is going to be the longest side length, which actually ends up being QR. So 3 times the square root of 5 is larger than 6. So A and B don't really matter. We can say this one is PQ, this one is RP. We're going to check if this equals QR. Plugging in 3 and 6 equals 3 root 5 squared. So 3 squared is 9 plus 36, so this ends up being 45. And if you recall, the 3 root 5 was originally the square root of 45. So if we square that, we end up with a 45. So this is true, meaning that the triangle PQR is a right triangle. And there you have it. So to recap the steps that we took, we created vectors PQ, QR, and RP, and found the magnitude of each of those vectors, which represent the side lengths of each of the triangles. And then using that information, we saw that all the side lengths were different, so this triangle could not be a isosceles. Finally, we used Pythagorean Theorem to see if the square of the two smaller lengths was equal to the square of the hypotenuse, and we found that that was true, so this is indeed a right angle triangle. Thank you for watching. The full solution to questions 7 and 8 will be available for download at MyHomeworkRewards.com. Remember, if you're looking for an adaptive learning system that automatically tailors the questions based off of your performance and allows you to earn rewards along the way, then check out MyHomeworkRewards.com. You can sign up for free and you can work on similar vector questions like this. We also have chemistry, biology, and physics, and even English questions. Thanks for watching.